Alright, let's take a look at some derivatives here. So I'm just going to do these really quickly. Follow along if you can. Slow down, pause if you need to, okay? Here we go. Number one, ready? 39 derivatives. Let's see how fast we can do these. So for the first one, we take the derivative. This is just our power rule. That's just going to give us what? 20x cubed to the fourth minus 20x cubed. There it is. There's our derivative. Look, I'm not even writing f prime. Here we have our product rule. The first times the derivative of the second plus the second times the derivative of the first. E to the x is just e to the x. Here, chain rule. So we would get this negative 1. That's going to give us x to the fourth plus 3x to the negative 2. Chain rule, derivative of the inside. 4x cubed plus 3. Don't forget the parentheses. And you should probably write that as the 2 power on bottom, but I want to go through these quickly. Oh, look, a product with a chain rule. So we would get the first. So 3x squared times the derivative of the second times 7x cubed plus 1 to the 6th. Chain rule times 3x squared plus the second x cubed plus 1 to the 7th times the derivative of the first, 6x. Look at that. He's a champion derivative taker. All right, this is a nasty one. Please rewrite it. This is cosine of x to the fourth. So when you do your chain rule, you're going to get 4 cosine of x cubed times the derivative of the inside, negative sine of x, minus here, that's just 4x. There we go. There you go. Don't forget, that was a really hard one right here. Oh no, number 6, this is our quotient rule. Low d high minus high d low, all over low, low. So low, 1 plus x squared d high, which is 1, minus high times the derivative of the top, of the bottom, d low, 2x, all over the bottom squared. And there's our derivative. Very easy. Clean that up if you need to. All right, number 7, I could use quotient rule, or I could split this fraction. I can go, this just becomes x minus 1 over x, which is just x minus x to the negative 1. Take the derivative, we get 1 plus, this becomes 1 over x squared right there, and there's your derivative. All right, very good. Check that if you need to. Here, I'm going to clean this up a little bit. I could do product rule. I can simplify. This is just 3x to the 5 halves, so my derivative therefore would be 15 halves x to the subtract 1, 3 halves. There's your derivative. Oh no, this one's not so friendly. I'm going to use my log property, split my log. I get the natural log of x plus the natural log of e to the 7x, which is just the natural log of x plus 7x. So the derivative, I'll do it over here, 1 over x plus 7. And there's my derivative. If otherwise you're looking at chain rule with the product rule, use your log properties here. Log, 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 log. All right, again for number 10, split this up. This becomes, let's see here, just 2x squared plus 3 minus x to the negative 2. If I split it up, and therefore our derivative, we get 4x plus 0. And this becomes plus, let's see, 2 over x cubed. And there's your derivative right there. Like I said, we're doing these really quickly. Check them if you need to. All right, product rule with the chain rule here. So this is just going to become, hello. So this just becomes x cubed times 2 minus x to the 1/5. So the derivative, the product rule, x cubed times the derivative of the second, 1/5, 2 minus x to the negative 4/5 times negative 1. Don't forget your chain rule. Plus the second, 2 minus x to the 1/5 times the derivative of the first, 3x squared. There's your derivative. You might want to put this on bottom if you need to. All right, over here, I'm just going to rewrite it. 2x minus 4x to the negative 1/2. So now for our derivative, we get 2 plus, bring down your power, 2x, we're going to subtract 1 to the negative 3 over 2. And there's your derivative. Look how fast these go. Wow, we're doing good. All right, over here. All right, and then things got real. All right, so let's see here. So number 13, this is our quotient rule. Low, x squared plus 7 to the x. The derivative of the top becomes 8 times 3x minus 1 times 3, chain rule, front-end power, minus high, 4, 3x minus 1 squared, d low, 2x plus, be careful, the derivative of 7 to the x is 7 to the x, natural log of the base. 7 all over the bottom squared. X squared plus 7 to the x squared. Wow. Okay. All right. Take the second derivative. All right. Next, we're going to get x squared plus 8 to the 1/2. Ready? Oh, that's just basic chain rule. After everything else, this one's not so bad. So we're going to get 1/2 x squared plus 8 to the negative half times 2x. Chain rule. Don't forget chain rule. All right, number 15. Here we go. Okay, so, hey, if you really love math, try this one. Ready? Okay, so I'm going to do number 15 down here. I'm just going to rewrite this, okay? So number 15, it is x over the square root of 1 minus the natural log of x squared. That's going to take a little bit more time. So I'm going to rewrite this as x over 1 minus the natural log of x squared to the 1/2. I can use, and let's see here. Take the derivative, quotient rule, low, 1 minus the natural log of x squared to the 1/2 times 1 minus high times the derivative of the bottom, which is 1/2, and this becomes 1 minus the natural log of x squared to the negative 1/2. Chain rule, derivative to the inside, this becomes negative 2 natural log of x, power rule, times the derivative to the inside, 1 over x, all over the bottom squared. 1 minus the natural log of x, it was to the 1/2 to the first. There's your derivative. All right. That is awesome if you can do that one. All right, now we normally don't like negative exponents, but you know what? I'm going to give the exception on this one, okay? All right, so let's take a look at number 16 here. 16, there's a couple ways I can do this. There's no x on top, so I can bring the entire thing to the top. 6, I go 3x squared minus pi to the negative 4. Therefore, the derivative, we're going to get this, just use power rule though, negative 24. 3x squared minus pi to the negative 5 times 6x. Don't forget your chain rule. Same thing over here. I'm just going to use my power rule here. I'm just drop down the 4. I'm going to get 4 over 6. This just becomes 3x squared minus pi x to the third. Oops, that's a weird looking 3 there. Come on. To the 3. Chain rule. Derivative of the inside. 6x minus pi. Now over here, the pi just became 0 when you took the derivative, but over here, pi x becomes just pi. Now be careful over here. I didn't need parentheses because it's a single term. Over here, you want your parentheses. And oh my gosh, what do I think for number 18? All right, I'm going to copy down number 18 down here. So give me a second. It is x over x squared plus the cube, the square root of 3x to the 5th. All right, here we go. I am going to use my quotient rule. You know, it's going to be fun when you see a big fraction bar. Low, hello, low, d high minus high, d low becomes, use your power rule here, chain rule, 5, let me put this as a parenthesis here, a dot instead, might look a little better, times x squared minus root 3x to the 4th, derivative of the inside, we're going to get 2x minus, now remember, this is the square root of 3 times the square root of x, so that's just minus the square root of 3, 1 over 2 root x, right there, all over the bottom squared. X squared plus root 3x to the 10th. There's your derivative. There's number 18 for you. All right. Number 19. Look how fun we're doing. Ah, this one's not so bad. Okay, we get to the pi. we do have a chain rule on the inside, so when we take the derivative, we're going to get pi x e to the x to the pi minus 1. Derivative of the inside, it's a product rule here. First times the derivative of the second, plus the second times the derivative of the first, which is just 1. There's your derivative. That's not too bad. All right. Number 20. All right, this is our derivative arctangent, so if you forgot that, pay attention here. So for number 20, it is a chain rule. We're going to get 10 arctangent of 2x to the 9th. The derivative of arctangent, 1 over 1 plus a squared, so that becomes 4x squared. Chain rule again, times 2. There's your derivative. All right, over here, oh my gosh, then we get any worse. Chain rule again. 1/2 e to the 2x plus e to the negative half. Derivative of the inside, e to the 2x times 2. Double chain rule on that. And then e just becomes 0. So there's your derivative. All right, where are we at now? Number 22. Oh my gosh. Product rule followed by 2 chain rules. This is going to be fun. So the first, x to the 6th plus 1 to the 5th times. Here we get 4x plus 7 squared times 4, chain rule, plus the second, 4x plus 7 cubed times the derivative of the first, which is 5x to the 6th plus 1 to the 4th times 6x to the 5th. And there you go. All right, 23, let's go. Yeah, not too bad. 23, just chain rule. Within a chain rule, how would you like your chain rule? So we're going to get 7x plus the square root of x squared plus 3 to the 5th. Derivative of the inside, we get 7 plus here, we're going to get 1/2 x squared plus 3 to the negative 1/2 times 2x. There you go. All right. Now for number 24, I could make this ugly, but I'm going to multiply everything by x squared. I'm going to get rid of use the LCD. I get x plus 1 over x squared minus 1. And that makes the derivative so much easier to do. Just the basic quotient rule. So we get low x squared minus 1, d high minus high, x plus 1, d low, all over the bottom squared. That wasn't so bad. All right, over here, again, I'm going to whoops, don't want that there. Over here, I am going to rewrite this as x to the x cubed to the, what's that, negative 3/2. So this is, so if I rewrite the whole thing, ready here, rewrite the whole thing, we would get x to the 2/3 minus x to the negative 3/2. So the derivative, we would get 2/3 x to the negative 1/3 plus 3/2 x to the negative 5/2. There we go. Over here, all right. A few ways we can do this one. I'm just going to get the derivative. 2x plus 5. I'm just going to rewrite it. 7x minus 9 to the 1/2. So we would get 1/2. All of this, blah blah blah, to the negative 1/2 times. Now we got chain quotient rule. Low. 7x minus 1 times 2 minus high, 2x plus 5 times the derivative of the bottom, which was 7, all over the bottom squared. 7x minus 9 squared. That should be minus 9. There. All right. Easy peasy. Oh, look, that's just tangent. How nice is that? That's just secant squared of x. Nice. All right, over here there's a few ways I can do product rule twice, or I can make it kind of easier for myself and just kind of distribute this. So I'm going to do that. This becomes e to the x times x squared plus 3 times x cubed plus 4, and I can just do product rule. The first, e to the x squared plus 3, during the second, 3x squared times the second, x cubed plus 4, the derivative of the first, product rule, e to the x times x 2x plus x squared times e to the x. And there we go, there's my derivative. I didn't think it's pretty, I just think it's mine. That's just a product quotient rule. You can do that one. This is a chain rule. I do want to take a look here because it's natural log. We would get 3 natural log 5x squared plus 9 squared times derivative of the inside is log 1 over 5x squared plus 9. Another chain rule times 10x. And there's your derivative. Same thing over here. Now this one I can actually use my log property and bring down the 3. I can write this as 3 natural log 5x squared plus 9. Now I can't do the log property here because 3 is on the outside, but here my inside's cubed. No property here, property here. So therefore the derivative would be 3 times 1 over 5x squared plus 9 times 10x. Your chain rule again. Derivative cotangent is negative cosecant squared, so we get negative cosecant squared of 6x times 6. Okay, that's hard to read. And make it look a little bit nicer. 6x times 6. All right, here we are going to use product rule. Secant squared. We get secant squared of x. Derivative tangent is secant squared of x plus a second tangent of x. Be very careful. Remember, secant squared is written like this. So 2 secant x times the derivative of the inside, which is secant x tan x. I'm pretty sure that cleans up very, very nicely, but we're not going to worry about that. All right, derivative of arc sine. Remember, this is just 1 over the square root of u squared minus 1. So we get 2 to the 2x minus 1 times the derivative of the inside. Derivative 2 to the x is 2 to the x natural log of 2. Don't forget that. Chain rule here. Derivative of the outside, we get secant squared of cosine of x. Derivative of the inside is just negative sine of x. There's your derivative. Over here, just chain rule. We get 3. Hello. We get 3. This becomes x squared minus 1 to the 5th minus x squared times the derivative of the inside. We get another chain rule. 5x squared minus 1 to the 4th times 2x minus 1. There we go. There's your derivative. Over here, just product rule. Derivative secant. This is secant x. Tangent of x. Derivative of the first times the second. I messed that up. That's okay. Order doesn't really matter for product rule. Plus the derivative of the second, which is 3 cosine 3x times the first. Secant of x. There's your derivative. Over here, oh, that's a nasty little quotient rule right here. Let's do the log one here first. The derivative of the log. So to take the derivative of the log, it's just going to be the following. Alright, derivative natural of log. This is just 1 over this 3x squared plus 4x times the natural log of the base, chain rule, times 6x plus 4. Alright, I'm going to do number 38 down here real quick. So 38, let's take a look here. 38 is just this x minus 1 cubed over x times x plus 3 to the 4th. Alright, here we go. Quotient rule. It's going to be fun. Low. Times the derivative of the top. 3x minus 1 squared minus high x minus 1 cubed d low. When I do the derivative of the bottom, though, I got a product rule. So the first times the derivative of the second, which is 4x plus 3 cubed. Chain rule is just times 1 plus the second. X plus 3 to the 4th times the derivative of the first, which is 1, all over the bottom squared. X times x plus 3 to the 4th squared, and there's your derivative. All right, look at that. 38 derivatives or 39 derivatives in 19 minutes. That was fun. See you soon. Bye-bye.